Hi, in this lesson we're going to learn how to assign values to a variable within Java. Mostly that's going to be about doing arithmetic in Java, but there will be a little bit that goes beyond that. So let's get started. The basic syntax of an assignment statement: to assign a value to a variable within Java, you write the target value, the target variable on the left side of the equal sign, like in these examples. Rate equals 45, or distance equals rate times 15.3. Java evaluates whatever's on the right side of the equal sign, and whatever value it gets, it puts it into the variable on the left side. So it does the right side first without even looking at the left side. When it gets a value, it puts it in the variable on the left. So some of the arithmetic operators that you have in Java are ones that you'd expect. Addition, subtraction, multiplication, and division, using a plus sign, a minus sign, an asterisk for multiplication, and the slash sign for division. But there's a couple of other things, some of which I'll highlight here. The plus sign usually means addition. That's if you've got numbers that you're doing. 6 plus 5 is 11. A variable that's an integer plus another variable that's an integer is an integer. But as we saw when we put together some strings in our first programming assignment, and you said, "Hello, person, I like that color too," you can concatenate strings using the plus sign. So the plus sign in Java is smart enough to know, is what I have on either side of me a string, or is it a number? And it will either mean addition or concatenation. The percent sign is an operator within Java that means remainder, or for those of you that have heard this term in a math class, modulus. It's what's left over when you divide by a particular number. We'll see some examples of all of these on the next page. Here's some examples. I'm going to have a variable j that's an integer, d that's a double, s that's a string. So here's some things that I can do. J equals 3 plus 5. That's arithmetic addition. The result is 8. D equals 3.1 plus 5.0. Those are all doubles. The result is 8.1. If I've got S equals, here's a string, hi, comma, blank, and another string, Mr. I, when you put it together, you get hi, Mr. I. I can do multiplication. J equals -2 times j. Notice I've got j on both sides of the equal sign. This is extremely common in programming. You don't see that in math. This doesn't mean the same as in math, where you can then subtract j from each side and find out that 0 equals -2. Remember, Java does what's on the right side of the equal sign, gets a value, then puts it in whatever's on the left. So whatever you had in j before, remember our last value for j was 8, you multiply by, well, here I've got an arithmetic error, you multiply by -2, you should get -16, not -24. Duh. Okay, you can do division. Division, you've got to watch out if you're using integers or doubles. Doubles can handle decimal points. Integers can't. So if I do double division, 3 divided by 2, I get 1.5. If I do integer division, 3 divided by 2 is just 1, because for integers, it will throw away everything to the right of the decimal point. So 3 divided by 2, when I do it with integers, is 1. Even if I assign it to a double, look at the third one from the bottom. D equals 3 divided by 2. Java will do what's on the right side of the equal sign first, and the right side is all integers. So it gets 3 divided by 2, and it says, that's just a 1, because it's an integer. Then it puts it into a double, and it makes it 1.0. You need to guard against this when you're doing division. Now here's some examples of the percent sign. 5% 2 means, what's the remainder when I divide 5 by 2? Since 5 divided by 2 is 2 with 1 left over, the result of this operation is a 1. 6% 2, on the other hand, is a 0. Notice this is a good way to tell even numbers from odd numbers. see what you get when you do a %2. Now, when we talked about that division example, we got into what's called mixed mode arithmetic. When you're performing arithmetic operations in Java, it's safest always to use the same type of data for each of your operands, all int or all double. Then you know what's going to happen. But when there's a binary operation on operands of a different type, the less inclusive type, int, is temporarily and automatically converted to the more inclusive type, double, before the operation is performed. So, if you had j is an integer, d is a double, and their values are 3 and 2, if I do dd equals j divided by d, int divided by a double, Java says, oh, an int and a double, I'd better use both of them as doubles. And it will do 3.0 divided by 2.0 and give you a value of 1.5. If you do j divided by 2, you get a value of 1 because there both of the operands on the right were int, so it doesn't automatically change. We can force some changing. This is called typecasting, by putting a type in parentheses. If I put parenthesis double parenthesis j divided by 2, it says apply that typecast double to whatever comes next. So I'm going to use the double version of j divided by 2. Now I've got a double divided by an integer. Double and integer, Java says I'll use double, and you get 1.5. If, however, I do double j divided by 2, it's going to do the j divided by 2 first because you put parentheses around it, giving you a 1, then turning it into a double. Need to really pay attention to mixed mode, especially when you're doing division. Now, you can assign from one type to another sometimes. The general rule is you can assign from a less inclusive type, like int, to a more inclusive type, but not the other way around. So let's say we've got n is an integer, value 5, d is a double, value 3, s is a string, value, quote, 1, 3, not the number 13, but the characters 1 and 3. If I do d equals n, this works. I can take an integer and move it into a double. If I do n equals d, the compiler will tell you, sorry, I can't do that. I cannot stuff a double into an integer. If I do s equals n, it'll say, nope, you can't put a number into a string. If you do n equals s, it'll tell you, nope, I can't put a string into a number. Those three won't even get past Eclipse. Now, if you have a string, like somebody's typed it in a dialog box, and you said, tell me the number of tiles that you want in this game, and they type in 1, 3, and you want to get that into a numeric variable so that you can use it for some calculations, it is possible to do it, but it doesn't happen automatically. You should use something that looks very complicated. Integer, spelled with a capital I, dot parseInt, is a method that is available for you in the Java utilitary library. So it's available in any program as long as you import the right thing, and Eclipse will give you a warning about where to import it from. If you say integer.parseInt and pass it a string, it gives you back an integer if whatever was in the string looks like numbers. So in this example, S had the characters 1, 3, that looks like a number, it'll turn it into the number 13. If S included the characters Mr. I, and you tried to do this, it would not work. Assignment operators. We saw whatever's on the right side goes into whatever's on the left side. But we can combine operators with the equal sign as a type of shorthand. Look at this. J plus equals 3 is a shorthand way of saying J equals J plus 3. I can do that with any of my operators. I could say J minus equals 3, J times equals 7, N% equals 2. It means the same as variable equals variable operator and then your other operand. Java programmers get really used to doing shorthand. Java programmers are lazy and like to type fewer characters. Another shorthand is increment and decrement operators. If you either do plus plus or minus minus with a numeric variable, it adds 1 or subtracts 1. So let's say j was a variable, an int with a value of 5, and k is just another variable. J plus plus means j equals j plus 1. So since j used to have a value of 5, now it has a value of 6. J minus minus, since j used to have a value of 6, now it's back to 5. K equals j plus plus. That says use the value of j, then increment it. So k gets the value of j before it did the plus plus. That is 5. Then j gets incremented. If you want to increment j first, you could do k equals plus plus j. Add 1 to j, it's now up to 7. Move the value into k. So they both would have a value of 7. There are some relational operators that work on things other than numbers. They work on anything that, well, they can work on numbers, but they give back a true or a false. You can say k greater than 6, or j less than k. Greater than or equal to, less than or equal to. Notice we use 2 equal signs to compare things. 1 equal sign means assign whatever's on the right to the left. If you want to compare two things to see if they have the same value, returning either true or false, you use equals equals. And if you use the exclamation mark and the equals, that means not equals.